we have seen what is continuity equation in rectangular coordinates and in polar coordinates, we have also learned about what is acceleration vector and velocity vector. Let us apply continuity equation and solve the following problem. Now, the problem says over here, the velocity vector for an incompressible flow is given as v is equals to 60 plus y z square I cap plus 3t plus xy square j cap plus xy minus 2xyz 6t square k cap. So this is what is given over here, velocity as a function of x, y, z and t, which is given to you. Now we have to split this velocity vector into individual components, that is ux, that is velocity along x direction, v, that is velocity along y direction, and w, that is velocity along z direction. We have to see whether it satisfies the continuity equation or not. Let us first solve this question to verify the continuity equation. So let us split this over here. So from the problem, you know that this is value of u, this is value of v, and this entire part is value of w. So now let us check whether it satisfies the continuity equation or not. So from the question we know that u is equals to, that is 6xt plus yz square, v which is equals to 3t plus xy square, and w is equals to xy minus of 2xyz minus of 6tz. Now let us differentiate u with respect to x. So that is dou u by dou x is equals to 6t. Then dou v by dou y is equals to, this part will be 0, so this will be 2xy, and dou w by dou z is equals to, this part will be 0, so this part will be equals to minus of 2xy minus of 6t. Now according to continuity equation, if we add this equation number 1, equation number 2 and equation number 3, if the addition of these three equation is 0, then the flow is possible or the flow isn't possible. So let us evaluate that. That is dou u by dou x plus dou v by dou y plus dou w by dou z is equals to 6t plus 2xy minus 2xy minus 6t. So these components will go away and we'll get this as 0. This entire continuity equation can be also written as del dot v bar, that is equals to 0. So hence flow is possible. Hence flow is possible. Now let us go to the next part, which says that calculate or determine the acceleration vector at point 4, 1, 2 at time t is equals to 3 seconds. So let us calculate the acceleration vector. Now the formula for acceleration vector, we already know that, that is a is equals to ax I cap plus ay j cap plus az k cap. Now these are the acceleration vectors, so we have to calculate ax, ay as well as az. Now let us calculate ax first. So we'll, ax is equals to dou u by dou t plus u dou u by dou x plus v dou u by dou y plus w dou u by dou z. So that means for calculating Ax, we have to differentiate u with respect to t, x, y and z. So let us calculate that part. So we know that u is equals to 6xt plus yz square. So dou u by dou t is equals to 6x. Next, dou u by dou x is equals to 6t. Dou u by dou y is equals to z square. Dou u rather by dou z is equals to 2yz. This part will be 0. So let us plug in the values in this equation. Now we have to calculate the acceleration vector at point 4 comma 1 comma 2 and time t is equals to 3 seconds. So let us directly substitute the value at x is equals to 4. So this will give us 24. This value at value of t is equals to, since here we don't have value of x, y and z, we'll just substitute the value of t, that is equals to 3 seconds. So that will give us 6 3s are, that is 18, and the value of z, which is equals to 2, will give us 4, and dou u by dou z, that will give us at value of 1 comma 2. So that will be 2 into 1 into 2, that will be 4. Now similarly, we'll calculate the velocities u, v, w at those respective junction, that is 4 comma 1 comma 2 and at time t is equals to 3. So let us calculate the value of u at coordinates 4 comma 1 comma 2 comma 3. So that will be equals to 6 into 4 into 3 plus y, that is 1 into z, that is 2 square. So this is 6 4s are, that is 24 plus into 3, that will be 72. 72 plus 4 will be 76. So this is 76 meters per second. Similarly, we'll calculate the value of v at 4 comma 1 comma 2 comma 3. So that will be equals to, we know that v is equals to, that is 3t plus xy square. So that is 3t plus xy square. Let us substitute the value, that is 3 into 3 plus value of x is 4 into value of y is 1 square, that is 1. So this will give us 9 plus 4, that is 13 meters per second. Similarly, the value of w from our previous equation is a function of, first we have to calculate this as 4 comma 1 comma 2 comma 3. From the previous function, this is xy minus 2xyz minus 6tz. So this will be equals to 4 into 1 minus of 2 into 4 into 1 into 2 minus of 6 into 3 into 2. So this will give us 4 minus 16 minus 6 3s are 18 into 2, that is 36. So this will give us a value minus 48 meters per second, that is velocity at w3. So now let us calculate the acceleration. Now we know that the acceleration component ax is equals to dou u by dou t plus u dou u by dou x plus v dou u by dou y plus w dou w by dou z. Now let us substitute these individual values, so which we have calculated in the previous sections, so which are equals to dou u by dou t is 24, so here this will be 24 plus value of u is 76, so value of u as 76, dou u by dou x which is 18, will substitute 18 plus dou value of dou u by dou y is 4, so let us substitute this as 4 plus some value of v, and dou u by dou z which we know is also 4, so let us substitute 4 over here. Now over the next part, the value of u and the value of v is 13 meters per second and the value of w is minus 48 meters per second, so this is 13 and this is minus 48. On evaluation of this, you get this ax as 1252 meters per second square. Now for calculating value of ay, we'll use a technique which is a shortcut. We'll write dou, since it is ay now, so we'll use dou v, we'll just write dou v again, plus we'll write dou v again, plus we'll write dou v again. So first we'll differentiate with t, then we'll differentiate with x, then we'll differentiate with y, then we'll differentiate with z, then we'll multiply u, v and w over here. Now let us differentiate v with respect to x, y, z, and these values we already know. So v from our question was given to, from our question was known to us, that is 3t square plus xy square. So this is 3t plus xy square. So dou v by dou t will be equals to 3 comma dou v by dou x will be equals to y square, dou v by dou y will be equals to 2xy, and at the last dou v by dou z will be equals to 0, since v is not a function of z. So now we'll substitute this in those individual parts. So what do we get over here? That is ay is equals to dou v by dou t plus u dou v by dou x plus v dou v by dou y plus w dou v by dou z. Let us substitute those individual values at those respective terms. So now let us see what is dou v by dou t. Dou v by dou t is a constant, that is 3. If we substitute the value of y equals to 1 in this equation, because we have to calculate the value at 4 comma 1 comma 2 comma 3. So x is equals to 4, y is equals to 1, z equals to 3, z equals to 2 and t is equals to 3. So this will give us as 1, and this value at x is equals to 4 and y is equals to 1 will give us 8. So let us substitute over here. Dou v by dou t was equals to 3 plus, from the previous part, u which we have evaluated from the previous part, we know that is equals to 76. So let us substitute this. This is equals to 76 into dou v by dou x dou v by dou x is 1 plus v, which we have already calculated in previous part, v as 13 and w as minus 48. So let us substitute 13 and minus 48, and dou v by dou y, which we have previously calculated as dou v by dou y as 8, and dou v by dou z is 0. So this will be 0 and this value will be 8. On calculation you get ay, which is equals to (183 meters per second square). Similarly, we'll calculate the value of az. For that, we'll write a as a function of x, y and z. So az, which is equals to, we'll use the technique again. We'll write this as dou w plus, we'll leave some space, dou w plus, we'll leave some space, dou w plus, we'll leave some space, dou w. First we'll differentiate with time, then we'll differentiate with x, then we'll differentiate with y, then we'll differentiate with z. And here we'll put the values u, v as well as w. Now we know from our problem that is w, which is equals to xy minus 2xy minus 6tz. So let us substitute, that is xy minus 2xyz minus 6tz. Now let us derivate with respect to x. Dou w by dou x is equals to y minus of 2yz minus 0. This will be 0, comma, dou w by dou y is equals to x minus 2xz, and this part will be 0, and dou w by dou z will be equals to 0 minus 2xy minus 6t, and dou w by dou t, that is equals to, these two parts will go away, will be left with 6z only. Now if you substitute those values at dou w by dou z at 4 comma 4 at 4 comma 1 comma 3 comma 4 comma 1 comma 2 comma 3, so what do we get over here is equals to, y has a value of 1 minus 2, y has a again value of 1, and z has a value of 2, so this will be equals to minus 3. Dou w by dou y over here is equals to, that is 4 minus of 2 into 4, value of z is equals to 2, so this will give us, that is 4 minus 16, that will be minus 12. Similarly, that is dou w by dou t, that will be equals to minus 6 into z, z has a value of 3, so that is minus of 18. And the last part, that is dou w by dou z, this is equals to minus of 2xy, so minus 2, x has a value of 4, y has a value of 1, minus 6 into 3. On solving this, we get dou w by dou z, that is equals to 8 and 18, so that is minus 26. So let us substitute back in those individual equations. So what do we get? This as Az is equals to, first we'll write down dou w by dou t plus u dou w by dou x plus v dou w by dou y plus w dou w by dou z. So this will be equals to, from the previous part we have already calculated all the values. So this is minus 18, minus 18, minus 18, mind you this part is x, so minus 3, minus minus 12 and minus 26. So this is minus 18, we'll leave some space, minus of 3, we'll leave some more space, and this will be minus 12 and we'll leave some more space, and this is minus of 26. This is multiplied by UV and W. UV and W we had previously calculated in a, that is u has a value of 13 and this w has a value of minus 48, and so let us substitute over here. So this is 13, this has a value of minus 48, and this has a value of 72. So on evaluating this part, Az is equals to 852 units or meters per second. Mind you, this is 76, not 72. This is 852 units. Now we know that a is equals to ax I cap plus ay j cap plus az k cap. So we can write down this as plus 852 k cap, which is value of az. Ax has a value from the previous part. Ax has a value of 1252 I cap plus ay has a value of 183 j cap. So we have represented this vector in ax, ay, az, I cap, j cap and k cap respectively. I hope you have understood how to solve the problem of acceleration vectors using continuity equations. Thank you.